And I'd like to see that more clearly by animating it and decomposing it. So here's an animated version, which I can then modify using the GamePad. And again, there's pi, and there's some fractions, so it's kind of typeset. So I'll go ahead and invoke that. And this is more complicated. This sort of looks somewhat like the curve in the other slide. But you can see here how here's one component of it's decomposed, and here's the other. And the frequency, amplitude, and phase of the first one are controlled by these three buttons, and the frequency, amplitude, and phase of the second one are controlled by these three buttons. So if I modify this, you can see how it changes the Lissajous curve. Right? Look at that. And of course, it's also updating down here. So if I do this, see how it's changing there? Now, obviously, if I connect this to the game interface, I can really go nuts here. See? Look at that. All those are Lissajous curves using these components. So really good, I would think, for experimenting and understanding. Look at that. That's a pretty one. Okay. Lissajous, animated and decomposed. Okay, let's see here. Colliding orbs. This shows two colliding interacting spheres. They have different colors, and the shadows are evident when we see the underside. So one is red, there's a sphere, and one is yellow. So this is not very much code we can see, and here's our animation. The centered sphere is red. It doesn't move, it just has a variable radius. The moving sphere is yellow. It also has a variable radius, and it's controlled by this position controller. And you can see it kind of goes through each other. So obviously that could be atoms or electron clouds or any number of things. Astronomy, any number of things. So let's connect it to the GamePad. And let's see what happens here. Oh, did it? No, I guess it didn't do it here. There we go. Let's try that. And so you can see I can spin it around. I can change the radius, or I could do it all kind of. And also when you spin it around, see how the bottom is dark? Because it's a light source. It has a light source on the top. So see this? Look how this. So that's pretty cool there for sure. And this is just, I don't know, maybe 10, 12 lines. Let's keep going here. Now, those are all geometric. Let's do a more artistic one. And even though this is also mathematics, it's really just a table of lines to points on a circle, which is what sines and cosines are. And this is only 4 lines. So it's not clear what this does. I'll try this. This looks like how many lines you have. Go down all the way to 1. And this looks like the position of the center. And so if I go to the gaming interface, looks like the center is controlled by this left rocker. And then the number of lines is controlled by the right rocker. And you can see how I can kind of do this all at once and goof around with it. Even before, when you get more lines, you can get a nice Moore effect. Pretty cool. I like it. You can really go whack on this thing. So that's 4 lines for an artistic application. And let's get even more artistic. This is 6 or 7 lines, very similar. A little bit more control, a little bit more variability. Let's see how this looks. And it's interesting, when this comes up, I always get confused as to exactly how to use it. So I'll start from the bottom here. You can see what that does. Looks like the density of the lines. And then this tells how much of a circle the arc is. And then this one, oh, look at that. See? Isn't that cool? And this controls it, I guess, the spinning. I don't know which one controls the number of lines. Anyway, let's go to the gaming interface. And we can really go nuts with this. See here? The number of lines goes way down. Oh, there's the number of lines. So actually, the last one is the number of lines. See there? Look at that. That's really cool, actually. So it's kind of artistic. Play around with it, find something that you like. And that's 6 or 7 lines, maybe. And then, just so that you don't think it's all artistic or geometrical, this is actually algebraic. So we're going to look at an expansion of a plus b to the n. And to me, this is artistic, even though it's a little bit weird. So I'm going to go ahead and invoke it. So it's a very simple alpha plus beta. And if I change n, it'll do alpha plus beta to the squared to the cubed. So look at that. See that? So what's cool is that you can even hook this to the GamePad. Now watch this. Let's see here. So like this. There we go. So I go all the way. 10, 19, 30. Now, this is just Mathematica is amazing. Look at this. 57. Look at this. See? Now to me, this is a little bit artistic. If you do this, look at that. Hold on. Let's go back. We're up to 73. See this here? See this here? Actually, I can widen this. Let's see if I can widen this a little bit. And then look at that, how it grows. It's basically organic. How incredible is that? Okay, now, so that's an algebraic example. So, lastly, the action. This is pretty intense. Lights, camera, action. So this was one we looked at before. We know how it works. It spins the lights. But look how I can do this. And then I can turn this on. And then I can still go crazy. And it figures out the lights. And I can slow them down and speed them up. Let's go a little slower. So obviously this could be astronomy. This could be a lot of things, obviously. Okay, pretty cool. I like that, actually. Now let's see. What have we talked about? Wrap up. We talked about manipulate. We talked about hooks to a gaming device. How the gaming device hooks to Mathematica. We looked at some geometrical examples. We looked at some artistic examples. And we even looked at an algebraic example. So now you know. So let's look at the lights code. It's a little bit more complicated. Colors, objects. So the objects are cylinders. Those are things on the stage. Here are the walls. Here's the light sources, directional, ambient. And then here's the animation. Obviously, it's more complicated. So thanks for watching. It was I would think it was very interesting. And